Hey everyone, I'm going to be moving on to dilations and its properties. Some of this we did learn in class, and I'll post a few more properties, and I'm sure it's on my PowerPoint, just so you can check it. We're going to give this a start. Start this one here. So what they mean by dilations and its properties is talking about the measure of the angles. Do they change? Do the side lengths change? Does it stay congruent? Does it stay similar? So those are the things we're going to have to know. So we have triangle A prime, B prime, C prime, which is not here, is resulting of the dilation of ABC by point P by a scale factor of 2, right? So the triangle was enlarged, that's all it's saying, by 2. So they want you to determine whether each claim about the properties for each triangles is either true or it's false. All right, so BC and line segment B prime, C prime are on the same line, right? So because we have to stay on the center of P, if we were to enlarge this by 2, it would still be on the same line. Because it has to stay with the center, and it would still get bigger. The line itself would get bigger, but they would be on the same line. So that's going to be true. And the other one is line segment AB and line segment A prime, B prime are both parallel to the x-axis. So that's this guy right here. And if this were to get bigger, it would still be parallel because we have a right triangle that's upside down. So that means that it is parallel, and you can give that a true. And I think that's all you have to do for this one. Yep. So you just have to kind of know your properties. Let's try the next one. So the quadrilateral A prime, B prime, C prime, D prime is a result of dilating quadrilateral ABCD about the point P by a scale factor of 3 divided by 2. Okay, so they want to know if these claims that are down here are true or they're false. So the lengths of line segment AD and line segment A prime, D prime are equal, right? Anytime you go under a dilation of more than 1 or less than 1, the side lengths are going to change. So this is going to be false because they're not going to be equal. Whether we know what the other side length is, we know it in dilations, as long as it's not 1, it's going to either get bigger or it's going to get smaller. So that's false. The areas of A, B, C, D and A prime, B prime, C prime, D prime are the same. Now let's think about this. So if we had a shape that was 2 by 2 by 2 by 2, the area would be 2 times 2, which is 4. If I do a scale factor to that shape, and I times each side by 2, so now the sides are 4 by 4, the area now would be 16, right? Because 4 times 4 is 16. So this has to be false, because they cannot be the same, right? And the only other thing I want to let you know is that the angle measures do not change, right? So whenever we make a shape bigger or smaller, the angle measures are staying the same. So you may see that question coming up, and if you have any other questions, you can let us know.